Okay, from first principles then, okay, so we got to derive it, say we know the answer before we start. I'm going to get minus 2x plus 4. So we need to draw a curve then. This time it's a negative x squared, so it looks something like that. So the first value of x, okay, I take 2 points P and Q. The first value of P will be my general x point, which is minus x squared plus 4x minus 6. I move the x value on by a gap of h, that's x plus h. And then whenever I see an x in this equation, I replace it with x plus h. Okay, so I work out the gradient of the chord PQ. So that's y2 minus y1 over x2 minus x1. So y2, that's minus x plus h all squared plus 4 x plus h minus 6 minus, and now in more than one term there, so you must use a bracket. It's minus x squared plus 4x minus 6 all over x plus h minus x. So that's minus, so I square that bracket, so that's square x, that's x squared, multiply them together and double it, that's plus 2xh, and square the last, that's plus h squared, plus 4 times x plus 4 times h minus 6, and then the second bracket minus minus is a plus x squared minus plus 4x minus 4x, and minus minus 6 is plus 6, and the bottom line is x plus h minus x, which is just h. So remove the first bracket then, so that's minus x squared minus 2xh minus h squared plus 4x plus 4h minus 6 plus x squared minus 4x plus 6 all over h. So we got minus x squared plus x squared. We got plus 4x minus 4x minus 6 plus 6. So the top line, that is minus 2xh minus h squared plus 4h all over h. H is a common factor on the top line. So that's h minus 2x minus h plus 4 all over h, and that h will cancel with that one. So the gradient of the chord PQ is minus 2x minus h plus 4. So now I let the point Q tends to P, so in the limit as h tends to 0, point Q tends to the point P, and then that chord is then a tangent, so the gradient of the tangent at P is equal to, and h is 0, minus 2x plus 4. So dy by dx, which stands the gradient of the tangent, is equal to minus 2x plus 4. That's the first part. And part B, I want to differentiate 5x to the 4/3 minus 9 over root x. So I rewrite these. So look at y, that's 5x to the 4/3, that one's okay. Right, root x is x to the half. So x to the half on the bottom, still not ready to differentiate. I need to bring that x to the half up to the top. And the x to the half on the bottom will come up as x to the minus half on top. Now I'm ready to differentiate it. So the 4/3 comes down, so that's 4 lots of 4/3 x to the power of, take 1 away from 4/3, so that's 3/3, 4/3 take away 3/3 is 1/3, then bring the minus half down, so that's plus 9 halves, x to the power of, take 1 away from a half, minus 1 half minus whole 1 is minus 3 halves. So that'll be 20 over 3 x to 1/3, and then it's plus 9 over 2, and negative power comes back underneath as a positive power.